Miss Collier explains!
Translations.
Our learning intentions today are to understand that a shape can be translated left, right, up or down, to be able to draw the result of a point or shape being translated in a certain direction, and to be able to describe a translation when given an original point or shape and the image point or shape. We will know we are successful when we can draw and describe translations. So today we're going to look at transformations and then look at our first transformation, which is translation. You may have learned in the past about flips, slides, and turns. All of these are transformations. A transformation is the act of moving a point or shape on the Cartesian plane. We're going to look at these again using more formal terms and practice some more complicated transformations. So instead of calling them flip, slide, and turn, for flip we will call it reflection, for slide we will call it translation, and for turn we call it rotation. So a translation is an object or point moving on the Cartesian plane. It is an isometric transformation. Transformation meaning it's undergone some change, which for translation is movement. The word isometric means having equal dimensions. That means that when you translate a shape, it does not change its size or its shape. The only thing that's changed is its location. A translation involves a shift in an object's position, either left, right, up or down, or a combination of these. Now, we know that translations are an isometric transformation, meaning its size and shape don't change. But another thing that doesn't change is its orientation. If I have a triangle and I translate it, it will stay in the same orientation. It will not have turned at all during a translation. Translations in everyday life. Anytime an object moves in a straight line, we are performing a translation. So in a dragster race along 300 meters of straight track, the main body of the car is translated down the track in a single direction. Okay, before we move on to the more specifics of translations, I want to talk about the overarching topic of transformations and the way in which we go about showing these mathematically. Whenever we're working with points or shapes on the Cartesian plane, we call them images. Once a point or a shape is transformed, either using translation, reflection, or rotation, then we call the new image the prime. So we have the image and we have the prime. Now we know that whenever we're plotting points on the Cartesian plane, we should always be using capital letters. We can then use these capital letters to represent that a shape has been transformed. For instance, let's say my first image was called A. Now this image is just a point on the Cartesian plane. I then can transform it, either through reflection, rotation, or translation. Once this point has been transformed, it is then called a prime. To represent this on the Cartesian plane, we use a little dash. So as you can see here, I still write A, but then I put this dash after it, representing that it is a prime. If you had an image that was transformed a number of times, we use multiple dashes. So if your image had been translated and then reflected, it would be called a prime prime. These are the rules for transformations, and we will use these anytime we're working with the Cartesian plane. These practices can be helpful so that we don't have to write out instructions in words. Like in this example, we have the words 5 units right, 2 units up, but if we didn't, we would still know what the original image is and which one was the prime. Because we can see in the blue image, they've got the capital letters, but in the pink image is obviously the prime because they have the little dashes after the letters. We can notice that this transformation is a translation because the shape has moved its position but hasn't changed its size, shape, or orientation. Now that we've covered the basics of transformations, let's look more specifically at translations themselves. We know that anytime we write coordinates for the Cartesian plane, we must do this in round brackets. For instance, if I had the coordinate 4, -2, this would mean that my image was in line with the 4 on the x-axis and the -2 on the y-axis. I know this because it's in round brackets indicating that they are coordinates. We can also use brackets to represent and communicate translations. But to make sure that we're not confused with coordinates, we use square brackets. In this example here, my shape would move 5 to the right and 2 up. How do I know this? Well, the square brackets represent to me that this is a translation. It tells me that my shape is going to move. Then the numbers help me to figure out how much. As always, the first number represents X and the second number represents Y. So the first number tells me how much my image is going to move from left to right along the X axis. If the number is positive, it's going to move towards the right because that's the direction of the positive numbers on the Cartesian plane. If the number is negative, then it would be moving to the left because that's the direction of the negative numbers on the Cartesian plane. My second number represents the Y and how much it's going to go up and down on the Cartesian plane along the Y axis. Positive numbers meaning it's going up and negative numbers meaning it's going down. So both of these numbers are positive, meaning it's moving 5 to the right and 2 up. Let's practice translating shapes. The question says, draw the image of the triangle ABC after a translation of 2 units to the right and 3 units down. Now I'm going to give you the biggest piece of advice when doing any sort of transformation. You should be doing it 1 point at a time. Don't try to transform an entire shape because you will usually end up distorting the image or making some of the points in the wrong spot. Instead, do the action to every point and then rejoin them afterwards. I'll show you what I mean. First, I'm going to translate point A, and it's 2 units to the right and 3 units down. So I'm going to count 1, 2, 1, 2, 3, pop a point, and then I'm going to write A. And because I've translated it, it's A prime. So I'm going to put a little dash afterwards. Now I'm going to translate point B, but I'm not going to assume where it is. I'm going to actually translate it. So 2 to the right, 1, 2, and 3 down, 1, 2, 3. That's B prime. And lastly, C prime. 2 to the right, 1, 2, 3 down, 1, 2, 3. C prime. Once I've done all of my points, then I will try to join them up. Now you should be joining them up with a ruler. I'm going to try on the iPad to go as straight as possible. Once I think I've translated my image, then I'm always going to check, does it seem reasonable? And does my shape look like it hasn't changed shape, size, or orientation? I think mine looks pretty good. It looks like it's moved 2 to the right and 3 units down, and it looks the same size shape. You try to translate this shape. Let's quickly check your answers. Draw the image of the triangle ABC after a translation of 1 unit left and 3 units down. So again, I'm going to do it point by point. A, 1 to the left, 1, 2, 3 down. That's A prime. B, 1 to the left, 1, 2, 3 down. B prime. Notice that B prime is sitting on the same spot as A. That's fine. And C, 1 to the left, 1, 2, 3 down. That's C prime. Now I'm going to connect them back up with a ruler and check for reasonableness. It looks like it's moved 1 to the left and 3 down, and it's stayed the same size, shape, and orientation. Okay, let's practice describing translations. My question says, a point B, 5, -2, is translated to B prime, -1, to describe the translation. So the first thing I have to do for this question is plot my points. So first of all, I know that they're coordinates because they're in round brackets. So I'm going to plot B, which is 5 on the x-axis and -2 on the y. So there's B. Now it has been translated to -1 on the x-axis and 2 on the y-axis. That's B prime. Now in this practice, we're just translating a point as our image. But this is actually kind of handy. If you ever have to describe the translation of a shape, it's actually best if you just check 1 point rather than trying to translate the whole shape. So it's great that we're practicing with 1 point. What I need to do now is figure out how much it's moved left to right and how much it's moved up and down. So first I'm going to go left to right. Now I've noticed it's moving to the left and it's moving 1, 2, 3, 4, 5, 6. And then how much is it moving up and down? Well, I'm starting at the B and I'm going up to B prime. So it's moving up and it's moving up 1, 2, 3, 4. So I've got left 6, up 4. But I shouldn't leave it like this. I should use my square brackets to communicate a translation. So I'm going to do square brackets. First, I want to do my left to right, which is 6. Now I need to figure out if it's positive or negative. Well, it's moved to the left, and the left is where our negative numbers sit on the Cartesian plane, which means it's moved in the negative direction. So it's -6. Then I do my comma, and now I'm looking at the up and down, which I have up and the number is 4. Now I have to figure out if it's positive or negative. Well, it's moved up, and the up is where the positive numbers are on the y-axis. So it's going to stay positive. So it's -6, 4, and closed bracket. You have a go at describing this translation. Let's check your answers. First, let's plot our point. So B is -2, 5. That's B. And then B prime is 4, -3. B prime. So now let's check how much it has moved. It has moved to the right. And how much has it moved? It's gone 1, 2, 3, 4, 5, 6. Now we need to look at our up and down. Well, it's moved down, and it's moved down 1, 2, 3, 4, 5, 6, 7, 8. So now we're going to draw it in brackets. I've got my square bracket. Now I'm looking at the left to right, and my number is 6. Now it's moving to the right, which is the positive side of the x-axis, so I'm going to leave it positive. I'm going to put my comma and then think about my y. For my up and down, my number is 8. Is it positive or negative? Well, it's moving down, which is the negative direction of the y-axis, so that's going to be -8, and square bracket. Translation of 6, -8. I hope now you can draw and describe translations using proper transformation procedures.